Good morning, students. I hope you're all nice and warm. It's pretty cold over here, I'm sure with you as well. We had a really good snowstorm. It's beautiful outside, but it is quite cold. So as you know, we're not having class today. We would have had a lab today and a quiz, so you should have your quiz by now. Go ahead and take that. In my opinion, it's kind of easier than it had to be, so you're welcome. And then I'll talk about what we would have been doing for our lab today. It was pretty simple stuff, kind of fun actually, so we'll save some of it. First of all, we talk about how we would look at the way that a gas is dissolved into a liquid and how it gets a higher ability to be dissolved in there when it's under pressure and also when it's cold. And so we would be doing a similar lab to what you're looking at this picture right here. I would have some Coke and put it in a cup, and one of the cups would be down into some warm water and one of the cups would be in cold water, and we would see the difference of the escaping bubbles that are coming from it. Now the next video I'm going to show you is something a little more sciencey. It has test tubes and stuff, and I might add this to this lab because it looks pretty fun. I have everything except for those really cool, awesome, tall beakers that you'll see. So if I can get a hold of some of those, I'd do that. So just watch this and see how it proceeds.
We're going to do a quick investigation involving solubility of gases in a liquid. To do this, it works better if you use a dark colored liquid. So we've selected grape crush soda. Guys, you want to go ahead and open these up and start to fill your test tubes. We have identical test tubes with a 1-hole stopper here and 3 beakers containing water at different temperatures. Jeff has a beaker of cold water. It's about 0 degrees. There's a small amount of ice still in it. I have room temperature water, which today is about 27 degrees. And Mike has the hot water. What we're going to do is simply fill our test tubes up with the soda without spilling. You can actually make this more quantitative if you predetermine exact temperatures for your hot, room temperature, and cold. It might work real nicely if you had 10 degrees higher, 10 degrees hotter, 10 degrees colder. And all we're going to do here is place our fingers over the stopper. We're going to invert it beneath the surface of the liquid. Once it's there, take it all the way down to the bottom. And then we're going to move these just a little bit closer together. We want to make our observations. One of the first things that you'd notice is going to be at the top of the test tubes. Now this one, for some reason, has got a lot more of the liquid.
One of the things you want to make sure of is when you
moving.
fill the test tubes is that when you put the stopper in, the liquid overflows so you don't have a container of gas at the top to
Right.
begin with.
Right? But as far as looking at the motion of the gases, this one's definitely moving a lot faster. When it's in the hot water, you can see the grape crush coming out of the bottom. You can see the level inside the test tube moving lower, lower, and lower. If you can zoom in on the hot solution, which is the third beaker here, look at the number of gas bubbles that you can see escaping along the sides. Is that real obvious to those of you in the audience? Okay, that tells you something right there, that the gas, carbon dioxide, which is providing the carbonation in this case, is going to be less soluble at the higher temperatures. And that's really clear. Let's take our tubes. We're just going to hold them up at about the same level, but let's not remove them from underneath the surface of the liquid. And we can see that the level of the crush has gone down most in the hot water. Probably the room temperature water would be second. We had a real big start with the cold for some reason, but it's really slowed down, and the room temperature water has now got more of the pop removed. Try it with your classes.
Okay, so I'm thinking probably the guy with the the cold water tube got a little bit of air in there, and that's why that bubble was so big. So it's good to know that I'm not the only one who has imperfect science experiments. All right, the next thing we would be doing is talking about our exothermic and endothermic reactions. And so you remember what those mean. If it's exothermic, that means it feels warm to the touch. It has energy that's being released. If it's endothermic, it feels cold to the touch. It's actually absorbing energy, the energy actually from your hand, the warmth from your hand. And so I have these really cool little packs similar to these hot packs right here, but they're more quantitative, that we could do an endothermic and an exothermic reaction, and we would take those and get those activated. In these ones you see on the screen right here, you end up breaking a little pouch inside there, which causes the chemicals to mix together, similar to like a glow stick or something. And then one of them causes cold and one of them causes heat, and then we would take our thermometers and measure the temperature on those. And you would write that lab up in your book there. The last part of our lab would be pretty exciting, although a little bit I don't know, using a lot of your energy, and that would be to make ice cream. All right, so we would take the ingredients and put it into a Ziploc bag. It would be cream and sugar and vanilla, and then we would put the Ziploc bag into another bag, which we would put into a bag filled with ice, and then we would do what is known as a freezing point depression. We would cause that ice to get even colder by adding something to it, and if you remember, adding a solid or a liquid to it is going to make our ice get colder. And in this particular case, you've probably made ice cream before. We are going to add salt to that. I've had this with some of my younger students do it. They literally take the bag and start shaking, and it takes a while for that to actually firm up and uses a lot of your muscular energy to do that. But we end up, of course, having delicious ice cream. Which is one of the favorite things about chemistry, is when you can make delicious things. So we may not repeat this experiment because of the time it takes. We would have had time during class to do it today, but we'll still talk about that freezing point depression and have something to do with ice cream as well. So you may want to go eat some ice cream today, or go make a snowball or something, or use some snow to make some ice cream at home. And anyway, have fun out there on your snow day. And like I said, I will save those science experiments for another time. Okay, gang. See you next week.